Hello and welcome to another video. Today we're going to be solving LeetCode 509 Fibonacci number. Feel free to pause the video just to read through this and understand what the question is actually asking for. However, I prefer to go through the examples as I find the examples a lot more descriptive than the actual question. Okay, it just pretty much said, given a number n, whatever n is, n equals 2 in this case, find the Fibonacci sequence of n, or the Fibonacci number at that point. Okay, in this example, the definition of Fibonacci is given. It's just if n equals 0, Fibonacci sequence of 0 should return 0. If n equals 1, Fibonacci of 1 should return 1. However, once it's past 1, Fibonacci of n should return Fibonacci of n minus 1 plus Fibonacci of n minus 2, which is pretty much the sum of the two numbers that come before that number in the Fibonacci series. Keep in mind that n is always going to be greater than 1. So let's just put our understanding of this on paper. So n equals 0, 1, 2, 3, 4, 5, and on to infinity and beyond. Okay, given this n, what is the Fibonacci of n? Okay, in the case of 0, like was given, Fibonacci of 0 should always give us 0. Fibonacci of 1 should give us 1, because if n less than or equal to 1, it returns n. However, once n is greater than 1, Fibonacci is the sum of the previous two. So Fibonacci of 2 is just going to be 1 plus 0, which is 1. Fibonacci of 3 is just going to be 1 plus 1, which is 2. Fibonacci of 4 is just 2 plus 1, which is 3. Fibonacci of 5 is just 3 plus 2, which is 5, and on and on and on as you go in the index. So it can go forever. So now that this is straightforward, let's go ahead and code this. As always, we tend to use our favorite language, Python. Over here with Pythons. Okay, so yeah, so just like we said, if n is less than 2, we just return n, okay, just like the description says here. Else, okay, we return Fibonacci. Oh, I did. I don't know what that means. We return Fibonacci of n minus 1 plus Fibonacci of n plus 1. Okay, this is pretty straightforward. Let's go ahead and run it. It gives us an error saying fib is not defined. Oh, okay. This is because every time you write a function inside of a class, you have to use the keyword self whenever you call this function. Especially, this is a case. This is just syntax with Python. Okay, so we have to do self dot Fibonacci, self dot Fibonacci. Let's go ahead and run it. It says maximum recursion, blah blah blah. Oh, okay. I made a mistake here. I said n plus 1. This should be n minus 1. So it caused this to go into somewhat of an infinite, not really, I'll call it somewhat of an infinite loop, even though there's no looping here. It's more like it kept adding numbers to the stack because I kept going up. If you keep adding to n, you can add from n equals 1 to infinity. You could just keep going. So let's go ahead and submit this. I'm pretty sure this is correct now. So let's see how we do. Wrong answer. So it says if the input is 2, we expect 1. Okay, if the input is 2, okay. And minus 2. I'm tripping, it's too early today. Okay, let's go. It's actually noon, it's lunchtime right now, bro. Oh, bam, okay. So this is not too bad. We're faster than 21% of people who use Python, and we're using less memory than 97. So in terms of space complexity, we're doing really good. In terms of time, we're not as good. So there's this problem is good, but there's one issue with it. Say we wanted the Fibonacci sequence of 1000. This is gonna run forever. It's gonna run too long. However, there's something called dynamic programming we can use to shorten the time. And again, I'm going to explain more in a later video, but let's just see what it is. I could create an empty dictionary. Okay, this is called dynamic programming or memorization, called memo. This is just an empty dictionary that's going to keep track of each of the Fibonacci sequence we've seen, so we don't have to calculate it again. Again, like I said, we'll explain this further. Okay, so then the first thing I can do is I can say if n in memo, if we have this element we're looking for, whatever the number is, if it's in memo, we just want to return memo of n. We just want to return Fibonacci number if he's in the dictionary. However, if he's not, we want to say memo of n. If it's not in there, whoa, okay, yeah, we don't need to do it there. If it's not in there in the else statement, we're gonna say memo of n equals this. Okay, so we want to save into that dictionary, and then we want to go ahead and return memo of n. Again, if you don't understand this, watch my next video. We're gonna touch this a lot further. Okay, so let's go ahead and submit this and see how we do. Okay, in terms of space, just because we're creating an extra dictionary and it's taking more space in memory, and this dictionary can go as long as n times, so we're using more space. However, we're a lot faster than we were before.